always keep forgetting that, right? So yeah, like I was saying, yeah, unfortunately, the 5% of the class that is vocal will say there is no problem when I ask you, is this working out? Can you learn well using this strategy? Can we try something else next week? Because, 100% of the country, 100% of the world really is experimenting with different ways of presenting the material to students to find out what works and what doesn't, right? And I think I've got some pretty good ways, right? The Zoom and me sitting here and talking to you and guiding you through the programming, I think is one of the best out there, right? Because other people are trying things and I can see, right, that's probably not going to work. It may not work for my students and so on and so forth. So I've basically given a lot of thought to this and figured out that this is probably the best way for me to get the information across so that you guys can start playing with the code yourself and get passionate about it. So it seems to be working, but at the same time, I always need feedback, right? I need to ask whether, because I'm making tweaks, right? Like these tweaks when you guys take over more of the screen time and start talking and I'm observing and just to guide you and nudge you in the right direction from time to time. So I want to see if that works because it's a tweak to the way that I teach. But unfortunately, when I ask that question, only the 5% of the people who are actually vocal enough to, bold enough to come on screen and answer me say, yes, it's working, right? Obviously, it's working because you're bold and you're asking. So, but what I want to know is that, is this working for the 95% of the people who are not answering this question, right? So when I ask if this is working, I can't ask the people for whom it is working, right? The small minority for whom it's working. I need to ask, is my strategy working for 95% of the people, right? Or the 100% of the people, or not just the 5% that it works, but does it work for everybody? So I can't really, I can't live in an illusory world, right? So Maya. So I can't live in an illusory world where everything that does not agree with my own senses is basically filtered out of my world, right? I don't even see it. And so there's 95% of the world, 95 my world, right? In this classroom, 95% of my students who don't understand what's going on, right? And they're simply just attending class and, and check mark on their notebook saying, well, 18 of 24 lectures done. Good, right? So they're doing that, which really is not learning C++ at all. And that's the majority of the world. But because I am so full of myself, right? So, well, hopefully I'm not full of myself, right? So if I'm full of myself, if I'm a narcissistic guy, and basically just say that, dissenters, right? Is people who don't agree with me, they don't exist, right? They don't exist. In fact, I'm only going to listen to the people that say yes. Right. So in fact, if you look at anyone, right, even people in great places, presidents of countries, right, they can choose to surround themselves with people, yes men, right, yes people, right. So they can choose to surround themselves, and the size of that pool could be big enough that it is a sufficient evidence to them, incorrect evidence, right, but it's sufficient evidence to them that their whole world is thinking like them, right. But the problem is that they have consciously shut off looking at everything else. So in their world, they're not even looking at the whole world, right? They're looking at a tiny sliver and thinking that's all there is, right? And so that if your mind, if a person's mind is only capable of processing a small amount of information, right? Very primitive stages of evolution, as mental, I shouldn't use the word evolution because it's a very scientific term, right? So development, right? So development, human development, right? So you can't process all of the information, right? So you restrict yourself to processing only a small amount of information. And in that small amount of information consists of only people that agree with you, right? So beyond that, your world doesn't even exist. But the fact is, we know that the world exists, right? We know everything exists out there, but I don't even see it because I'm so full of myself. I can't see anything that doesn't agree with me. And so if I ask questions, saying, does this work? If I do something and does it work? I have to be careful to ask the question and accept answers from everybody, not just the people who agree with me. And so I want to prevent that from happening in our class, right? I know everybody knows that this happens everywhere, right? Anywhere there's a power structure, people will surround themselves with people that, support them rather than work against them, right? So, and then it insidiously it builds a world around you, and walls around you, so that you can't look past these walls. And unfortunately, if that is a reality, as a whole world outside of these walls, which is going on, things are happening in that world that you don't even know, because that's being shielded from you. One day, everything could just come crashing in, and this bubble could implode, right? So you don't want to be in that situation. So, and I think that is the reason why I want to ask that, I need answers from people who are not bold, right? People who have not come. So, however, I want to prefix that, right? So there might be a person in class who is not interested in C++, who's just there because, they need a check mark on their transcript to go to some other college and say, I've done CS2A, BC, and so on and so forth, right? So they're not interested. And they find in week 6 that they're, the material is completely challenging, as they don't understand what's going on, and they ask questions about quest 2 and quest 3, right? In week 7 or 8, when and then they're not getting answers from classmates because they've all moved on. All of their classmates are working on higher number quests or advanced concepts, and then they get frustrated because they're okay, so Ben just said he's very interested, but still on quest 3. Are you interested in what I'm saying, or are you interested in quest? Because if he's interested in what I'm saying, I can talk, but otherwise I can, we can move on to talking about actual subject matter. But basically, the people who are working on the very early quests, very late, right? Very late. And when and they get frustrated. And I made a post in the Reddit forums, right? Don't make a post when you're frustrated. And it's because when you see everybody else out there and you're working here and you're still blocked, that creates a great degree of frustration, right? It's great, and it creates anger. If you're not careful, frustration leads to anger, right? So it creates anger because, and the frustration says, well, you can't solve this, but nobody wants to think of themselves as, unskilled or not able to do it, or not having invested enough effort. So they would tell themselves, I'm a good guy. I put in a lot of effort and still couldn't solve it. So the problem is not with me. The problem is someone else. The problem is all these classmates who are not helping me because they've gone ahead and they're not helping me because they want to get, or the instructor, the professor, he's getting paid a salary and he's not doing his job. He's not teaching me even though he's getting money. Right? And so what kind of shitty class is this? And you complain. So all of that. So when you find yourself making these things, you have to ask yourself, is this right? Just step back and ask, because the goal of this class, any of my classes, right? Well, not even classes, anything I teach, right? Anything I teach, my goal is not to give you the information, right? So if you ask me for the information, I'm going to say no. I can't give you the information. Go to some other class. I'm pretty sure that you won't find any good teacher giving you the information, right? Directly. My goal is not to give you the information, is to make you find the information, right? If you are not able to find the information by yourself, that's a good sign. It's a good sign for you that C++ and programming or computer science is not your cup of tea, right? Maybe you're wasting your time. You're wasting your time learning programming when you could actually have been, learning English literature and changing the whole world, right? Creating a whole entire new genre of literature. Maybe you are able to do that, but you're wasting your time in programming, right? So that's a sign. So those are signs that people have to look at in their own lives and not just listen to other people, right? Maybe they're in Silicon Valley and they're surrounded by people, they're all programmers, high profile people in software companies. They say, you got to learn to program. You got to learn to program. You are a programmer. You're a programmer, right? But that person knows they're not a programmer. They know their heart is in painting or ceramics, some other thing where they're going to make a huge splash in the whole world, right? They know in their heart, but everybody else is telling them, no, this is the way to success, right? You got to be a programmer. And then once you get a BS or a computer science degree, I have clout in my company. I'll set you up as a on track to become a big star in this company or something like that. I'll give you a track record. I'll fund you to do a startup if you do, and all kinds of false information really is impacting us every moment when we're young, right? Because people are promising you things in the hope that you will follow their dream. Right? Everybody who promises you things, they're hoping that you will follow their dream, because they're always happy to help you as long as you're following their dream. And when you're young, I think it's very easy to get misled and thinking, oh, I have a supporter who has made a name for themselves, right? And who's willing to support me to make a similar name. But unfortunately, that similar name is not what your forte is, right? That you may make a name for yourself somewhere else, but that person cannot see it, right? So you have to be wise enough to see, right? So who was actually telling me that here is a skill that you can pick up and see if it's your cup of tea. And if it's your cup of tea, you can use the skill to do great things, right? If it's not your cup of tea, leave it there, right? Leave it there. And now you know what it's all about. Go do something else that you want to do, right? Try it all, and then come back, and then you know it's still there. So at some point in life, when you decide that, you know, this is my cup of tea, then you already have, you have a running start, right? You don't have to start from scratch because you've already done 2A. You know what it's all about. You know what, caused you to go away from there, but you know what caused you to come back also, right? But if you have a bitter experience and then you say, wow, I had horrible experience in CS2A and nobody taught me, the professor was like totally silent and I was stuck and I had no idea what to do, and I'm gonna get away from here, then that is a bad way to leave a person or a subject, right? So if you leave a person, on good terms, you can always come back, and you can have a good time later on when you happen to have a chance running and so on, right? But if you leave a person on bad terms, you're never going to get together again. So likewise with the subject, right? If you're going to leave CS2A or computer science, leave it on good terms, thinking that, well, you know what, right now it doesn't fit into my schedule, right? I have all these things to do, but that I'm actually really, really interested in acting now, right? And that's where I'm going to focus, right? If maybe later on I find out that's really not, or maybe I can bring computer science to bear on this new skill that I've learned, right? Maybe you've learned acting, right? So you went to the acting department and learned acting, gave up computer science and learned acting, and you did some, you acted in various things and you made a name for yourself and you're a good actor. At that time, you will sit back and think, well, you know what? I've done a lot of really great things in acting, but I happened to pick up that skill 20 years ago, computer science, which I left, right? But there are things in acting that I can't do as a human, but I think I can bring computer science to bear on this, right? So maybe I can bring Unreal, right? The power of the Unreal Engine to do the stunt scene for me with an actor that I need to interact with, right? So but I can go and hire who's this Von Dam or something, right? Some stunt actor, right? So I can come and I can pay him like $1 million to do the stunt scene for me. So I'm going to create that actor in Unreal, right? And then I'll do my part, and then my counterpart, the other actor, will be played by Unreal. So, but how do I do that? But I know CS2A, and I know how computers work. But I went away because let me go back and try now. Now, after 20 years, you come back to computer science with a different domain knowledge in your head already, and you know what to do, right? Because that is the crucial difference between the two times you approached computer science, right? Is the first time, and same, approaching a person, right? The first time you approach someone and you're looking for something, right? But you're looking for something that is, all you narcissistic and full of yourself, and you don't find it, you go away, right? And you're not going to come back. But on the other hand, when you are looking for something that is, for the other person, actually, that's a bad analogy, right? So, computer science, you come back, you have a plan. You have a plan in your mind. You're looking for something, right? So when you're looking for something, everything that you see now, you can say, well, I can adapt that. I can adapt that. Well, I learned that. I learned looping 20 years ago, but I didn't really have a chance to use it, right? Now I can use looping because I know that this guy, Von Dam guy, always does his leg kick 5 times or 10 times, to knock out his opponent, right? So it's a special move that you engineer into your system, right? So you can do all these crazy things in computer science, you bring it back. So I think that is why I think having a product in mind, having any it can be a lame product, it can be nothing at all. It may be something that you're just going to show your younger brothers and sisters, right? So but it's important to have something in mind. So some product. That's why in class we're always, every time we start coding, we try and think up something, right? We try and think up, is there something that we can code today? Is there a game? Is there something that we can do that's fun, right? Because unless we have something that's fun and we're coding towards it, the skill we learn is not going to latch on to anything. It'll just disappear, right? At the end of class, it's gone. Yeah, and forget that. On the other hand, if you use looping to build something that day, like a game or something, then it sticks in your mind. So that's why I think that it's very important to, when we learn something, is to learn something with an object in mind, right? So with an objective, not an object, but with an objective in mind. And yeah, and the reason we ended up here is because we started talking about people that are not vocal needing to chime in, right? So you need to pipe up and say, yes, I find this interesting and useful, even though I'm not one of these people who have been contributing or been vocal so far, right? I'm not Chad or Ben or Susanna or Michael, who else? Dave Anand last week. Who else came here? Peter, Robert. Yeah, so I remember, all these people who came up on screen, and I know who hasn't come up here. Yeah, and so I think I absolutely need to hear from those of you, right? Be bold. I can tell you, right? If you're not bold, you're not going to make it in computer science. Well, any subject really, but computer science especially. If you're not bold, you're going to create programs with bugs, and you're going to be shy to ask other people if there's a bug. You're going to be shy to release it. You're going to be shy to take feedback, and your program will probably die, right? Within a couple of weeks of writing it, nobody's going to use it, and it can be out there, but you have to overcome that shyness, and 2A is the best place for you to overcome the shyness. Okay, you're not going to overcome that shyness in 2B. I can tell you, if you're shy in 2A, you're dead in 2B. Right? Because if you're shy to ask a question in 2A that you think is too fundamental and other people are going to laugh at you because you asked that question, in 2B, you would not even enroll in 2B, right? Because in 2B, those questions, people would not even read those questions. The first few words, and they say it's too basic, right? So they would say, ask this question in 2A, or you got to be bold. That is the first thing, whether it's math or computer science or pottery, whatever it is, right? So you got So ask questions and let me know if this is not working. Hey, by the way, Ben, you got a paper copy of Absolute C++. This is like this thick, right? Is it this thick? I don't know. Yeah? I can hear him. But yeah, but I think someone posted that there is a cheap electronic version of the book.
Yeah, I just needed a photocopy to be able to read.
You have to photocopy it?
Not a photocopy, an actual copy that helps me save my eyeballs.
Oh, I see. Okay, yeah. All right. Yeah, I think it has advantages. The paper copy. Okay, all right, no worries. But by the way, it is, Absolute C++, just so it doesn't overwhelm other students, we're not covering the whole book, okay, in 2A. In 2A, it's only, that much of that book, I think, right? Just the what I call control structures. Control structures meaning how to drive, basically how to drive, that's all, right? How to drive. So in 2A, you learn how to drive. In 2B, you learn the maps.
Take donuts.
Yeah, layout of land. Okay. In 2C, you learn how to go places. Okay. Now you know how to drive.
Off-road and stuff. All good. I get you.
Great. Okay. So who was that, by the way? Someone who didn't talk, who hasn't spoken before, or someone who has spoken? I don't know. So I couldn't tell here. Maybe it was Ben, because your box is outlined with yellow. All right, so we can start coding today, and I think what I'd like to do is start coding with an example that uses an. We've done loops, right? We're not going to do loops. We'll do arrays, and then we'll do functions, right? In fact, what we'll do today is, I think, create a program that uses both functions and arrays. Okay. In fact, what we'll do is create a, let's see, and of course you can correct me or we can change courses. We'll see if it works. Okay. We'll create a function in main. You're going to call that function from main, and in that function we'll use an array to do stuff and return a value. And then we'll change the program to make main create the array. Oh, you know what? Let's do it this way. Let's create an array in main. Okay, create an array in main, and then fill the array with some values, and then pass the array to a function, and have the function manipulate the array or do something with the array, and return a value. And then main will print the value. How's that? It's very simple, isn't it? Then that function, we can make it as sophisticated or complex as we want. We can play with the function. We can play with, you know, what's being passed, and I can use that opportunity to talk about what happens when a function is called, right? So I can do that also. Is that okay with you guys?
Sounds good.
All right. So how about someone pick up the screen, and then we'll drive from there. All right, so let me see, who have we got here? So can someone who has never been on screen before, you know, I ask this every time, but I understand it if you're actually at work, okay, and you cannot type, that's fine. But if you're at home, and you should just be able to, you know, join. I'm just waiting, right, for someone to pick up the screen. And let's see. Eden, have you been on screen before? You know, I think this is the only way it's going to work. If I basically call out people, and if it results in you guys not even showing up in class because I'm calling you out to participate and you're not showing up, that essentially means that you're not getting any participation points, okay? At the end of quarter, if I see that some people have been in 2A, right? Some people, although my lectures are optional, if I see that some of you have missed more than half the classes, right? If you've missed more than half the classes, that means you will actually miss more than half of your participation points, right? So if you've attended 50% of the classes, or at least I don't see you, right? And you're not interacting and so on and so forth. You're just there and you haven't attended classes. That's basically 7 out of 15. 7 out of 15 for your participation points, which means the maximum you can ever get, even if you ace your quests, your exams and midterm, everything, quizzes, everything, is a 93. And a 93 is not an A+, yes? Okay, 97 plus, over 97 is an A+, I think. So 93 is not an A+. If you've not been attending class, your A+ is out of the question right now. You're not getting an A+. Okay, so maybe you don't want an A+, right? So only people that probably want to go on to major in computer science, they want A's and A++. Maybe you're happy with a B+, okay? So that's fine. But if you want an A grade, you got to show up in class and also be active, right? I can guarantee, right? At the end of the quarter, I will sit down and look at every one of the names, right? Every one of the names. Before I fill in the final grade, I look at the names and I'll say, well, do I remember that person? Did they contribute in Reddit? Did they contribute in class? I don't remember the name. I don't remember the Reddit ID. I can't match it to the person. Okay, well, I don't know, maybe between 2 and 5 points, all right? So maybe, 1 or 2 points. That's all out of 15. And and then after that, you can't, there's no point in emailing me after you get the grades saying, hey, I aced everything and I still got only a B+, or I got a C. I got a C even though I did everything really well. How is that possible? And now you know why it's possible, right? So how it's possible. So you can say, go back, you can look at your participation. You got 0 for participation. That's why you got a C. There's 0 for participation, and you got 80% in your tests. 80%, which is usually a good grade, right? If you got 80% in your tests and quests, and you got a decent participation grade, you're almost certain to get something like B or B+, something like that. But if you didn't, then you're stuck with a C. And you may be thinking, oh, I got a B, my GPA is good, right? So, but unfortunately, that won't be the case. So here you go. This is your chance, okay? If you're actually in this class for a grade, okay, as opposed to just getting a check mark on your transcript saying, okay, it's pass with a C, or pass, no pass, right? So pass, no pass, or a C, and check. You can go on to something else. By the way, for 2B, there is actually a recommendation, even on the syllabus or even on at the Foothill My Portal, I think maybe it may come up, right? If you didn't get a B or better in 2A, the system says don't enroll in 2B, right? Not even me. I think for 2B and 2C, the requirement is that you have to get a B or better in the prereq course. Okay. Aiden?
When you're talking about participation, but does that apply to like if I've missed like 1 or 2 classes already?
Yeah.
Okay.
Yeah, one or two classes fine. I'm just talking about people that are, you know,
Or less than half, right?
less than half. Yeah, is
Okay.
systemically absent, right? They just enroll and they're absent, and and they may be here, but they're logged. You know, I'm so for example, I call out to Aiden and he does not answer, and I think, well, maybe he's at work, right? Maybe he's at work and he can't answer. But maybe I call out 4 or 5 times, right? Today, different lectures, and every time I get exactly the same thing, and not even via chat, right? In chat, hey, sorry, Anand and classmates, I'm at work. I can't verbally participate. Then I know, all right? But if there is absolutely no interaction and the name just shows up, you know, at the end of the quarter, I actually have no grads, right? Because I cannot distinguish a person who is showing up on my Zoom screen, but otherwise presents no evidence of being present, meaning that not even chat response or verbal response. No, none of those, and no evidence of having watched the YouTube video or commented or participated in Reddit in a way that is, you know, meaningful participation. That person basically no participation points. Yeah. But you know, 1 or 2 times you can be absent. You know, in fact, you can, if you've been a participant in class and answering questions even 1 or 2 times, like Susanna, right? Susanna, I think she's been on the screen exactly once, I think, on the very first class or second class maybe, right? It doesn't matter because I see her in class every time, and I know that she chimes in from time to time, right? So when someone else says something, she does actually chime in. So I know, right? Even if she doesn't come up on screen and, you know, code, I know when it comes time to assign participation points, I know, you know, Susanna is an active participant in class. She helps students out, right? But I can't say the same thing for other students, right? Other students will end up this time, right? So, I don't want that misconception to linger. So I'm going to put a stop to it this quarter. There is a misconception among students that I'm a very generous professor who just hands out lots of points at the end, right? You know, gives you second chances ad infinitum and so on and so forth. And I think that's a misconception. Maybe I will be a little generous, not so generous in 2A. Definitely, I don't want to be so generous in 2B and 2C, right? So in 2A, maybe be a little bit generous, not as much as before, which means that, you know, if you didn't put the work in, it is not a good, it's not good for you, right? I don't mean it's because I'm here to do good for you. I'm not here to do good for me, for the others, right? For each one of you, right? So if you didn't do any work at all and I give you a B, people may think, hey, that was a generous professor and he was good to me, right? He was good to me and I got something good out of this course because I got a B even for doing very little work. Because if I go on to, you know, Reddit or the Foothill Discord, Foothill Discord or even Reddit Discord, Foothill Reddit, Foothill sub Reddit, right? You know, people, not even Foothill, any course, or even if I log on to some public discussion forum at Harvard, right, or Stanford, it's less, but not completely absent, right? There still are students who are asking in these subs and forums on Discord, saying, which of these professors, which course should I do for the least amount of work, right? Which is an easy A, which is an easy. So why are students asking, even at top institutions, why are students asking, which is an easy A? That's a really stupid question to ask, right? You should ask, which class should I do to get the most out of it, right? What is a class I can get the most knowledge out of, not the most grades out of, right? Because the grades you'll forget. If you still remember that you got an A in 2A 20 years from now, then you're as good as dead, really, right? Because it's worthless. It's a worthless piece of information that you're carrying with you. Why does a grade matter? In 20 years' time, you're not going to remember 2A, or hopefully not going to remember me, right? Or a particular professor, or a particular, all you have is the knowledge, right? That is what stays with you until you die. All of us, everything else in the world will disappear, will come, enter your life, and go out. Enter your life, go out. Some people will enter your life, stay a long time, and then go out, right? The only thing that ever stays with you forever, you know, is the knowledge you built in, right? Until you have, you know, neurodegenerative stuff, but that is what stays with you, and you can't. So yeah. So you can't. So when I say I can be doing good to you, to give you points for something that you didn't do, right? So I can. So by giving you a C for work that is only worth a C, I'm actually doing you a good turn, right? Because it gives you a good signal. The teachers that are there to give you a good signal as to how much you've learned and how much more you have to learn. So if I tell you you got a C, that means that you got more, you got a lot more to do, look forward to, right? You got a lot more to look forward to in C++. Okay, so
My input to that, it's good advice that I got from a colleague was for language courses, which I think actually does apply to computer science. We do, even though we're a lot more technical than a normal language, we do have our own style vocabulary, our own style of grammar. We call our code we code in a language.
yeah.
And in a language course, to be frank, if you know what is getting tested on the test, you know it's getting tested on the quiz, and you've understood the formula for certain sentence structures, it's quite simple to get an A. But you don't really learn any of the language itself if you don't practice it and you don't actually learn it. And then you're going to end up you're going to end up in a bad place for the next language section and the next language section, the next language section. And at some point, it's more of like, how far can you get by kind of scamming your way through a language course without actually practicing and learning the material? And I guess that's sort of my input there, is like, it's something for a computer science course like Java, C, Python. You can get by doing something like using very simple code, or not using very good practices, or not making very efficient code. You could probably get by with like a B even, or in some courses an A. But you end up getting to 1B or 1C or 2B or 2C or 3B or 3C, and things get a lot harder, and you're like, wait, did we learn looping at some point? Was I supposed to learn that? Oh shoot.
Yeah,
Something like that.
exactly. Yeah, practice and nailing the concepts is more important than the superficial structures. Yeah, exactly. Yeah, I totally agree, Peter. Yes, and that is, if you look at science, right? The way, the business of science, the professional science or real science, right? This is how it works. Is you can't perform every single experiment on Earth, right? So what we do in science is perform a few experiments, carefully calculated experiments, right? So selected experiments, so that by doing this, we can understand the underlying concept. Right, so we don't do every single experiment, we just do some to but if there is a person who says, I've done 10 million experiments, right, 10 million different experiments, and I can do any one of those experiments really, really well, but they don't understand the concept, they only know 10 million experiments, right? But someone who knows the concept can now perform an infinite number of experiments. But if you learn each one of those experiments separately, then you only have a discrete number of, that, and that, like, Java, Python, C++. So you can learn the superficial aspects and only be an expert in that area, or you can learn the deep aspects. Once you learn the deep aspects, you're an expert in every single area. Yeah, thank you. Yeah, I think that is exactly it, right? Especially for languages, it's important to keep practicing, right? So it's not important to, it's not sufficient to just read. A lot of people, I was in that position, right? I made the mistake very, very early on in my life. I learned that lesson because in math, right? It's not in computer science. This is before the days when, people in computer science was a proper subject, right? It was there, it was being taught, but maybe it was very early stages of computer science. But my struggle was in math when before the exam, right? Before the math exam, and I bet, those of you who are doing, you guys who are doing math, you can relate to what I'm saying right now, right? So before the exam, I would open the book and I look at all the proofs. I say, yeah, okay, this proof is straightforward. It's simple, right? I read through the proofs. This is simple. Yeah, I can understand. I understand all the proofs. And I understand all the proofs, and I go to the exam. And in the exam, I get a proof, and exactly the same proof that I read before, but I get stuck. And it's very deceptive, because when you read things, you can understand it, but you understand that particular way of doing it. Right? And then you read something else, you understand that particular way of doing it. But my problem was that I was understanding each of those particular ways, but I was not at that time, right? At that time, I was not yet mentally mature enough to factor what it is out of that path, that particular proof that's important, right? So I know that particular proof, and I can work it out. And it's another proof, another proof. I could work out 100 different proofs, right? Easily, right? And I know, but it took a great deal more effort than that to be able to abstract out what is it that I'm trying to prove, right? Why do I need to try to prove this, right? And how, and those methods that need to click. And I don't know, right? I don't know if it's possible to teach that to someone, because nobody ever taught me that. And I don't know how I was myself able to distill out the commonality in those different proofs. Maybe there is a way, I don't know. I'm not an expert in education technology, but yeah, education, maybe there's, but it happens, right? It happens someday, suddenly, right? So you got to keep doing lots and lots of different things, practice, right? What Peter said, practice, practice, practice. And all of a sudden, without you knowing, I don't know, in my case, or maybe with me knowing and I forgot, right? It just, something happens. I think this is what happens, right? I think it happens. So I think we're doing lots and lots of things repeatedly, and then our brain suddenly kicks in and says, are you crazy? Why are you slogging away? Why are you slogging away doing these million different tasks one after another, right? Same thing over and over again. Just look at what's common and just memorize that, right? So you don't have to remember a million things. You just need to remember one thing, right? So I think that kicks in. And that kicks in only after you've done a lot of work, a lot of grunt work, and you start feeling, my God, this is grunt work. I don't want to do it. When you start feeling like that, that's when I think your brain basically kicks in and says, okay, well, that really is grunt work. Let's try and figure out if there's an easy way, right? And when your brain, some deep level, starts saying, well, that is too much. I'm too lazy. I'm not going to do this anymore. I'm just going to try and look for a shortcut, an easy way to do this. That is when you start abstracting things out and saying, well, I don't want to do this, right? Ultimately, I just want to do this, right? So I need to do, so you understand the concept. And I think concept understanding needs to boil out. And for, non-trivial tasks like programming or anything that's non-trivial, it takes a little while and it's only practice, right? And I don't know if you can consciously look for, if you're doing only one proof in mathematics, writing only one program in computer science, I don't know if it's possible to write one program or, work out one proof in mathematics and then sit down and look at, okay, well, I've done it. Now I'm going to look at it and abstract out what is the essential, what is the most important thing in that proof, right? What is the most important thing in that program? I need to abstract it out so that now later on when I need to do a different program, I don't need to, fiddle with that, because I can just use, it doesn't happen like that. So for me, right? So you have to do many of these things many times, and so that what is common between all of those will emerge in your mind, right? Emerge. I can't tell you, right? I can give you one program and say, well, this is what is going to be common in the next 50 programs you're going to write. No, it doesn't work like that, right? So you got to be doing this. You got to be doing this repeatedly so that in your own mind, you can find out, well, I'm doing this repeatedly. How can I make my own work less? Right? And when you get to the point when you say, I want to make my own work less, that's when your brain will start figuring out what's common, what can be abstracted out, right? Instead of doing, ax plus bx plus c, ax plus bx plus cx, you can say x times a plus b plus c, right? So, so you can, and your brain automatically starts doing that. And the only way you can get your brain to that state is by continuously practicing, right? Practicing and getting to the point where you're starting to think, I'm doing too much work, right? So you got to get to the point where you're doing too much work, or you think you're doing too much work. That's your signal to your brain to say, okay, now go and try to figure out an easy way.
Funny story about that. I think what you just said opened my mind a little bit. I've been struggling in calculus a lot this quarter. And I think I just found the reason is because I'm not practicing my guy.
Yeah.
I'm just reading it. You're right. I'm gonna have to reevaluate that. Thank you.
Yeah, but the one thing that worked for me, I can tell you, is although it's not computer science, it works in computer science too, right? In math, this worked for me, and try it out and tell me later on if it works, right? So reading through all these proofs didn't work for me, right? Because I think I understand, but I actually didn't understand but after I read through it, if I just don't look at it and try to do the same proof on my own, right? So because, you read through proof and you say, well, it's easy, I can work it out, right? So and then you try and close the book and work through the proof on your own. It's in calculus, right? Work through the proof on your own. If you didn't understand it, you will find out right then and there. And I didn't do that. I didn't do that step. I didn't do the step where you open a book math book, right? And partly because, you know, I was like you guys, some of you guys, probably not like you guys, right? Maybe a few of you guys, right? Where I would only open
Maybe
my
sounds
book
like me.
like 2 weeks before the exam. Right, and 2 weeks before the exam, I got to read that book, and so at that time, I can't really afford to work through every one of those proofs. So I just read through the proofs and say, oh yeah, okay, makes sense. Yeah, finished all of that. I really didn't understand anything. But then later on, I realized that, well, it's not enough to read it, but just one more step, right? While it's still in my head, thinking it's straightforward and easy, I can understand it. Let me test if I really understand it. And the only way I can test if I really understand it is I close the book and I work it out on my own, right? If I work it out on my own and I cannot work it out on my own, if I really understand it, I can work it out. And 90% of the time, I find out that I can't work it out on my own, even though I knew, or I thought I knew that I understood it, you know, when you work it out on, and I think that worked for me. Try it out and see if it works for you, right? Because, you know, reading through it and thinking that it all makes sense is really very, very misleading. And you know, I don't know, maybe overconfidence, right? So yeah, when I was younger, I used to be a whole lot more overconfident too, right? So young people are always very overconfident. You know, they think they can do a lot more things, and so especially with proofs. And you think, oh, it's simple. I can do this. Bro, this program I can write, right? And then when you actually do it, you just figure, oh my gosh, there's this bug. I have no idea how to solve this. So, all right. So how about well, Aiden is obviously not here today. Fear. I hope you have no fear. All right. Can you go on screen? How do you pronounce your name? Fear?
Yes.
Fear. Okay. All right. So yeah, you wanna take your screen?
Sure. Yeah.
Okay. How do you pronounce your last name? Shu?
Sure.
Yeah, sure.
Okay. So
All right. Hit Control Plus a couple of times. Make the. Do
Control
you have a
plus.
wider screen than others? Do you have a?
Yeah, I have the ultra wide.
Yeah. Okay. Just reduce the size, the width of the window, and then hit Control Plus to make the font bigger. Is this a PC or a Mac?
It's a PC.
Okay. All right. Yeah. Control Plus. Great.
It's now better.
Yeah, that looks a whole lot better. Thank you very much. Is it possible to actually? It doesn't matter. I was thinking whether we should change the names from Chinese to English on the left, but it doesn't matter. We're just working on the right in the program panel. Don't worry.
Okay.
Don't worry. Yeah, we can program. That's fine.
I didn't see the
Maybe I can
setting.
learn some Chinese
I
alongside it.
think it should be fine. I think most people have ASTS and kind of get the gist of the layout for VS.
Yeah, exactly. All right, so here's what we'll do. And I can call out the code, or anyone else can call out the code too. So you got to tell me what you want to do. I can call out the code, and then you guys can participate if necessary, or or you take over if necessary. So here's what we want to do. In main, I'm going to create an array of some numbers. Let's just say numbers for now, right? So create an array of numbers, and then I want to pass this array of numbers to a function that can, let's say, we want to do something simple with a function. Did we do this already? Well, yeah, we actually did calculate the mean of 5 numbers. Yes, previously in expressions, we did calculate the mean of 5 numbers. Now let's take that to the next level, right? So we'll create a function called calculate mean, another function called calculate, median or standard deviation, variation, all these things, right? So you can read interesting things, maximum, minimum, and so on. And then from main, we're going to call that function, get the return value, and print it out. That's all. It's very simple. And then and once we've got the function, we can kind of try and play around with it and take it to the next level and so on and so forth. Okay? Is that okay? Is that a good plan with all of you guys?
Sounds good to me.
Okay.
Yeah.
Great.
Yeah, I probably need some help though.
No, actually, Fear, you don't have to do anything at all. In fact, you're welcome to. But I want to say, right, just in case other people are wondering, right? So people who haven't been on stage before, you don't have to do absolutely anything, right? You just come up on screen and then I'll talk you through it. You just have to be a typist, and you'll find that just being a typist itself is like hugely valuable, because you end up remembering like 500% more if you're a typist not even paying attention, right? Being just a typist, you remember a lot more. Okay. All right.
Okay.
Yeah. All right. So now let's go into into your main method. Complete the main method. Declaration, not declaration. The title of the main method. So int main, open close, open close. You got to open. You got to also open and close. Open close. Yeah. Yeah, and then a space there, a space, and then a brace. You know, people usually have a space there. That's why I say space. Okay, great. And now between those two is where the body of the function is going to go. Now I'm going to create something called an array, right? An array is basically a group of identical objects, right? No, not identical. Identically typed objects. Yeah, it has to be, all objects have to be exactly the same size. You can't have an array that has an integer and a long, right? And then a string. You can't have multiple types in an array. The reason will become very clear very soon, right? So if you have a bunch of objects of exactly the same size, you can basically put them all one after another in memory, right? The reason we do that is because if they're all one after another, if I want to access the 50th object, I don't have to start at the beginning and then step 50 times to get here. Because they're all exactly the same size, I can go to the first object, whose memory address I know, and then I know the size of each object, right? Let's say 10 bytes, right? I know this object is exactly, 50th object, right? So it's 49 before it. So 49 times 10, 490 bytes down, I'll find the 50th object. Does that make sense? So instead of going to the beginning of the array and walking down to the 50th object, if every object is exactly the same size, I can directly index into the 50th objects instead of going up there.
Yes, it makes sense.
Okay, right. So that's very important. It is the it is primary, right? I think it's probably the only reason why arrays are so damn powerful and important, right? Because they give you constant time access to every element in the array. Okay, so let's create an array of integers. Let's say, so, and the syntax to create an array of integers is int, and then say, my array, and then square bracket, open, square bracket, and then say 10 inside square brackets. I think you say 10, right? 10. 10. We're going to try a few different things here because I've forgotten the exact syntax. I've been using vectors for so long, not native arrays, that I've forgotten the exact syntax now. Right? So in my array of 10 equals, and then we'll just initialize it right there. And then I'll show you other ways of initializing it too, right? So open curly brace, open curly brace. Yeah, is that a curly brace or a square brace? Yeah, curly brace, curly. Yeah, okay. Now, now type in 10 random numbers with a comma between them, right? So type in, punch some numbers, two-digit numbers, right? Yeah. Other people can call in too, right? 1, 3.
When wants to say some numbers, or I just type in?
Yeah. Go ahead. Yeah, we just want to get it filled up as soon as possible, right? So you need 7 more numbers. Just put in 7 more numbers, 7 more two-digit numbers. Yeah. Is that 10 numbers? No.
That's 9 numbers, actually.
Yeah, one more. Okay, all right. So, and then a semicolon after the brace. Okay, that's my array. Now, wow, it actually does this cleanup. Nice. Okay, on the next line, let's just do a very, very basic, a loop, right? We're not doing functions yet. Do a loop in the next, enter one more time, blank line, because it's, we want to do a very simple loop that loops 1 to 10 and print out each element on one line, okay? So you want to do for, yeah, exactly. Thank you, Fier. Okay, for size t, open curly, not curly, parentheses, open parentheses, shift 9.
Okay.
Shift 9, yeah, okay. Now size, lowercase s, size underscore t, size underscore t, okay, space, so j equals 0. No, lowercase j, yeah, j J equals, your keyboard is also, yeah, J equals 0. Yeah, semicolon. J is less than the size of the array, which is 10, right? Size of the J is less than 10. Yeah, J plus plus. Semicolon, yeah, J plus plus. Yeah, space after the semicolon is nicer. Yeah, thank you. Yeah, all right. Yeah, okay, close parentheses. And on the next line, you say, yeah, next line. Yeah, C out. Left shift. Yeah. Yeah, okay. And then within quotes, with double quote, my array, and then square bracket. It doesn't have to be square bracket. My array space elem, 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 and then element, and then put the pound sign, the hash mark, pound sign. No, pound sign, hash mark, pound, shift 3, I think. Yeah, and then after the double quote, after the go on, yeah, and then left shift I. Yeah, and then left shift. And then say is, space on both sides. Yes, within quotes.
Wait a sec. I think it's not supposed to be I.
Yeah, it's J, sorry.
Because I've used I a lot for loops.
So double quote, space, is, is, yeah, space. Okay, and then after the double quote, left shift, then my array, square bracket J, square bracket. Yeah, so open square bracket, J inside of that, yeah. And then at the end, you want an end line, end line. Yeah, semicolon. Now, semicolon, end semicolon. Now, in order for this to work, you need to use namespace at the top, which we can do, right? Yeah, you can using namespace, standard. Yeah, semicolon. All right. I think it's using, not using. Yeah, I think it's using. I don't know which language uses use. Is it use in Python?
No.
This one is C++, but I'm also taking the Python too.
Oh, I think in Python it's import, right? It's import in Python.
Yeah, it's import.
Yeah.
Okay. All right. So, so get rid of the blank lines. Just leave one blank line under above main. Just leave one blank line, so it's cleaner. Okay. All right. Now at the end, before main ends, you need to return 0. Yeah.
Small comment. But I've seen people put plus before the J in their for loop. And I understand the difference in general between putting it before and after. I was wondering for specifically a for loop, why sometimes I see that doesn't make a difference.
Oh, yeah, it's just stylistic, I think.
Okay.
Yeah, you can also later on you can experiment. You can you switch and see if it makes any difference, right? Because J++ here is a statement on its own. The plus operator is only meaningful when the term, the variable that's being incremented or decremented is part of a larger expression. So if the J++ was part of a larger expression, then the expression is evaluated and then the plus is done, right? If it was, or if it's on this side, it's incremented and then the expression is evaluated. Here, it's part of a larger expression, but the expression is basically a null expression, right? So there's only J++. So it doesn't matter if nothing is done before or after. here the expression that J++ is part of is a nothing expression. Yes. Okay, nobody's answering. So
Yes.
here, so within comments, right? Put two forward slashes there. Okay, so here is an expression which uses J++, which is part of another expression. Okay, so for example, I could have an expression that says x equals J++ times 5. Times 5, right? Or even x equals J++ is also fine. That's an expression, right? X equals J++. Just remove the times 5. X equals J++. Right, semicolon. Right? Now, that is an expression in which J++ is part of the expression itself. This is a very important distinction that everybody has to understand. So I need to know. Everybody should chime in and say, yes, I do understand this. J++ is part of another expression. Yes or no?
It's because J++ has to be incremented.
Yes.
I mean, J has to be incremented.
X equals J++ itself is an expression, right? In C++, that is it is a nuance. It's, even in Java and many other languages, when you assign something to something, that is an expression. The whole thing is an expression because that expression returns a value. X equals J++ returns a value. Maybe that's confusing, right? So let's make it so that instead of X equals J++, turn that into X times J++, right? Make that X times J++. Okay, all right. Now it's a whole lot clearer, right? Now it is very, very clear that J++ is part of a larger expression, which involves J++. Yes?
Yep.
Okay, good. In this situation, the plus matters, which side it goes. However, if I didn't have the X star, because X it needs to be evaluated. After the increment, it needs to be evaluated, right? But if I didn't have the X star and I just had J++ as an expression on its own, right? Then what's left is basically a nothing expression. So it doesn't matter whether the nothing is evaluated after or before. Anyway, this will all make more sense after you try it out, a few times on your own. Okay, so get rid of the comment. You can run it right now, and then we'll see the output, and we'll make sure that it's actually the array exists. Okay, yeah, run it, and you should see the output. Why is it taking this long to run the program? It's compiled it. Or do you have errors? No errors. Why is it taking this long to run? What's going on? Hey, you just disappeared off here. What happened to your program? Why did it run it now? Oh, actually, I wasn't even looking at the output. So yeah, the output is right there. Because it's in Chinese, I was looking at, this looks like error messages to me, right? But the output is right there above, right? So it actually does work. It printed all the numbers, 1, 2, 108. Thank you. So someone should chime in, right? Say, hey, it's there. You should tell me that. Okay, right. Go back to your ID. Go back to your ID.
I just did.
You did? I didn't hear you, Ben. I didn't hear you at all.
Because my screen, if I share the whole screen and then there will be ultra wide, so I have to share it individual stuff. So
don't worry. Go back to that other thing, IDE.
Okay.
All right, good. So now we know that the array is there and it has values in it. Now let's try something. Okay, we're going to define a function, right? Go above main, and say find maximum, find max. And it's going to return a value, right? So it's going to return int find max, find underscore max, right? find find. Yeah, find underscore max, right? So, and this is going to take an array as an input, right? So open parentheses, and you're going to pass it an array. So just call it array. You're going to give it whatever is being passed in. You need a handle to hold on to it, right? You can call it anything you want. Just call it A, or or call it array or AR, whatever it is, right? So array, but we need to tell the compiler what array is. So we're going to declare the type of array right there inside of parentheses. Go inside the parentheses, and you say int space, and then after the array, put in close or open close square brackets. That tells the compiler that array is actually an array. Right? Maybe we shouldn't be using the word array as the parameter name because it's confusing when I say it. But all right, so that tells a, because it is a here's a nuance, okay, and it's only for C++, not necessarily for Java, Python. In C++, when you pass a native array, this is a native array. We're not talking about vectors yet, right? Native array to a function, it does not pass the whole array. What it does is it only passes the address, the pointer, the memory address where the first location of the array is stored. Okay, so in that case, in this case, it is only going to pass the address, the memory address where number 12 is stored in memory. Okay, so it's really freaky, isn't it? It only tells what the function gets passed is the address where number 12 is stored. It doesn't know where 47 and it can only calculate, right? It can only calculate where the rest of the numbers are stored. It only gets the address of the first number. Okay, only 12. So how does it know where the remaining numbers are? It knows it by two ways, right? So it knows that the remaining numbers are immediately after, because it's an array, they all got to be packed one after another. So it knows that, and it also knows that the type of each of these elements is what? Int, because that we've told it, right? In the signature of find max, we said it's an int array, right? Integers of 4 bytes long. So it knows that the first element is here, the next element is going to be the address of the first element plus 4. Okay, then the element after that is going to be the address of the first element plus 8 and so on. Okay, so this function knows that it can find all the elements given the first element and the type of the element. So far, is that clear?
Yes.
Okay, good.
Yeah,
No.
so that's why it doesn't have to like iterate through, right?
No, it has to iterate. Now it has to iterate
Okay.
now, right? It does have to iterate. But there is a problem. There is a problem, right? I'm leading you towards a problem, and then we'll use vector, okay? So, but lots of people, especially people coming from Python and Java, they start using vectors right from day one, right? In C++, and they never get to know the nuances of arrays. Now, that's why I say we're going to be using vectors for the rest of the course, right? For the 2A, rest of 2A, only vectors, 2B, 2C, all vectors. We're going to be using vectors because vectors are so convenient. But it is, I think, bad to start using vectors from day one. We got to use arrays, understand arrays. After you understand arrays, then use vectors, right? Then you can go. Even you can talk to a Python programmer who may be using arrays in lists, right? In bad ways. They don't know, right? They know Python. They know, but they may be using an algorithm, an advanced algorithm, and the algorithm could be running in a very inefficient way because they're using arrays or Python lists without understanding exactly how it's being stored, right? So that's why understanding how arrays work is very important. Now, there is a crucial piece of missing information right there, okay? So suppose, for example, and we'll find out what it is, right? So go into the body of the function. We'll go into the body of the function, and we're going to flesh it out now. So this function has got to find the maximum of those values and return it, okay? So, and we'll do what a scientist does here. We're going to assume that something is correct, and then test it. This is how science works, right? Science works, but if you don't have any basis, we don't have any theory. So we're going to form a theory, form a hypothesis, but we're not going to say wed to that hypothesis. We're not going to say this is the only truth. This is, so we're going to say here's the truth, right? But we don't know. It's a tentative truth. It's possible to be true, right? We're going to test it. So my hypothesis is going to be 12 is a maximum number. Okay, I'm going to say 12 is a maximum number. That's my hypothesis. You got to have a hypothesis, right? So 12, I'm going to hypothesis, but I'm not going to be a stupid scientist. I'm going to say, here's my hypothesis. 12 is the maximum number, but I'm going to be a good scientist, meaning I'm going to let you test it. I'm going to test it myself. The best scientists are the people that test their own ideas, right? So I got 12. Now let me see, is the next number bigger than 12? Oh my gosh, the next number, what is the next number? 43, okay, 43, it is actually bigger than 12. So my hypothesis that 12 was the biggest number is wrong. Yes, so a good scientist always correct themselves, right? So I say, okay, my hypothesis was incorrect, so I'm going to revise it. My Newton's theory is not correct, right? It works in most of the cases when I'm only able to see the first number, okay? I got the whole array, but my visibility is so limited that I can only see the first number. So as long as I can only see the first number, my hypothesis is right? Newton's theories are correct, as long as I can only see so much of the universe, right? But when my telescopes get big, my observation is better, right? It seems like a lot of if else. No, in fact, no. See here, we'll do this in a very cool way. Okay. So Ben, yeah, good questions to ask. Yeah. Okay. So in fact, it is a lot of if else's, but you don't have to type it out. You don't have to type it out. There's a lot of it. In fact, there's going to be 10 as big as if the array has got 50,000 elements, there's going to be 50,000 if statements in there. But you don't have to type in 50,000. That's why we're going to use a loop.
As long as I don't have to type it, good.
Yeah, exactly. Right. So so we're going to say 12. No, 43. I'm going to change my hypothesis. Right. Good scientist changes. Now 43 is the biggest number. You keep going. Oh, 99 is even bigger than 43. So I was wrong. So I'm going to toss that away. Right. So not even Einstein's theory. Right. Some other theory which subsumes electricity, gravitation, everything. Right. Everything. So keep changing. So not we're not so blind faith and just stuck to something even in face of contradictory evidence, right? So we just change, and that's how we can manage to move towards what is correct, right? Otherwise, we're stuck where we're wrong, right? The only way we can move towards what is correct is basically being able to revise our own stance on issues. So we start with 12, no, 43, right? Oh, actually, no, 56. No, 53, no, right? We're still going to stick with 56. 67. Okay, that's what we're going to do, right? So we'll assume for now that the array has got a size of greater than 1, okay? So which means that we're going to assume that the array has 1 element at least. So we'll say that int max equals array of 0, right? Because that's a dangerous statement to make, isn't it? You can't make a statement saying array of 0. What if the array didn't have any elements? Then you're accessing an element that doesn't belong to you. It'll cause a memory exception and kill your program. We're going to make an assumption, a dangerous assumption, which we'll fix very soon. Okay, so say int max equals array of 0. Array. No. Int max equals max equals on the other side of equals. Say array of 0. Array square bracket 0. Okay, semicolon, right? Now start a for loop, right? So start a for loop, which iterates through all the elements of the array. And then each element is going to check by comparing to max. And if it's greater than the max, then you change your hypothesis as to what the max is. Does that make sense? And then when you've done the entire array, scan through the entire array, whatever is in max is the max, you can return it. Now, is that plan? Is it a high-level plan? Does that plan work for you guys? Do you understand the plan? Are you okay with that plan? This is the plan to find the maximum value.
Can you say that again?
So we're going to start and iterate through the array, 1 element at a time, comparing each element to what we currently assume to be the max. If it is bigger than the max, then we change the max value. That's now the max value.
Good. I got it. Yeah.
We're going to do that for every element. So iterate through every element in the array and set your value.
Professor, I have a question. So, I kind of like lost to, because I also taking the Python a set of time. So sometimes for the C++, when we wanted to go inside the array for each one, so I don't really, I am confused about how to go inside because
you already went inside. On line number 8, you said array square bracket 0. You see that?
Yes.
Yeah, that is actually going inside the array and getting the first element.
Yeah. Yes. For the for loop, because you wanted to get each number in the array and then compare it to the one before, and then maybe
not to the one before. You want to compare it to max. What you currently think is max.
Oh yeah, that's true. Yeah.
All right, I'll talk you through it, and then we can talk about it if you still don't understand. Is that okay?
Okay. Yeah.
Unless someone else wants to talk them through it, that's fine too. If someone else wants to talk them through it, that's fine. Otherwise, I'll talk them through it, right? I'm actually not looking at the chat window, so yeah, Susanna apparently sent something. No, Susanna, that won't work. That won't work. I'll show you why. Okay, Susanna, are you hearing? Yeah.
Yeah, I typed the wrong thing into the wrong window.
Yeah.
Sorry.
Okay. yeah, the algorithm you got there, you can try it out absolutely and find out why it doesn't work. But we'll try it out here. Okay. So here for int j equals 0. Now, yeah, space 0 semicolon, and then j less than, what should that number be?
I think so.
11.
Less than the number of arrays, less than 10, because that's our size of array.
But you still want to compare the 10th. Oh, wait, because 0 is the index, the first one. So 10. Or is it 9?
Could we do size of array?
Array
Or
size?
maybe length, the length of the array.
Yeah.
So how do you know? So that's a very good question, isn't it? It says, so, and in fact, this is exactly where I wanted you guys to go, right? How do you know what the size of the array is? Let's find out, okay? Let's find out, okay. So here, on the, comment out line 8 and 9, comment out line 8 and 9. So this is what we're doing, right? We're doing experiments. Comment the both. No, comment out. Put 2 slashes in the front of both of those lines for now, and also the first line. Okay. So below the comments, just do a C out. Yeah, enter. C out. Shift. Right. Size off. Yeah, open. Yeah, I think you don't need a parentheses there. Array, and then end out. Because size of is a compiler directive, right? So, okay, run it now. Now it should print the size of the array, but you'll see what it prints, right? You'll see what the value is. Oh, can you? I think you can see the output by increasing the size of the bottom.
I think you forgot to put in find max.
It failed. Actually, it failed. He say you should return a value.
You need to return a.
It needs to be in
return 0.
parentheses.
Just return 0.
Oh yeah.
Just return 0. Not the return 0.
Yeah, and you didn't call the method as well, so you have a
yeah, that's right. Thank you, Chad. Okay, you got to call the method. Okay, so get rid of the line 17 and 18. Get rid of the 17 and 18 because those were, we just testing, right? So get rid of the lines. Okay, you can comment it.
And for this to work the way we want it to, when we have to divide it by the number of
yeah, exactly. We're going there. Thank you, Tom.
Oh, okay. Sorry.
Yeah. Hey, call the function. Call the function on line. Yeah, enter before the return. Yeah, yeah, and call the function. Find max and pass it the array. Pass it a parameter. The parameter should be your array, my array. Yeah, now you should be able to run it now. Semicolon. Yeah, you should be able to run it, and you'll see what the size. It should print the size at the top. Before you should print the size basically. Where did it print the size?
Do you want to show you guys because it shows like 4. The result is 4.
Where is it? I don't see it. No, you don't have to do that. Fear. Go back to your screen. I'll show you what to do. Right? Go back to your. No, don't do that. Go back to your IDE. Yeah.
Okay.
Just drag that bar and increase it. Increase the bottom panel size. Increase the bottom panel size. Yeah. Okay. We still don't. Where is the 4? Maybe so you got to scroll up a bit. In the bottom panel, scroll down a bit. Scroll a little bit in the bottom. No, in the bottom panel, your 4 is there somewhere up there. No.
It probably I run on the local Windows.
I don't know where your terminal is. Your terminal should be here. It should be docked. Why isn't your terminal docked in the IDE? What is this? Is this Oh, it's Visual Studio.
Yeah,
Even
Visual
in
Studio.
Visual Studio, you should have a console. You should have a console. In Visual Studio, you should have a console somewhere.
Console somewhere.
I,
Right.
I think the console was the one he was showing us
Yeah.
Why is
earlier.
it docked? Why is the console not docked here?
It's a different thing in the Visual
No,
Studio.
no, no. It is a. Anyway, we'll figure it out later.
I think I might have figured.
Yeah, there's
Can you
Visual
try?
Studio
I
and
see
Visual
the-
Studio Code.
Yeah, do it later. Okay, doesn't matter now. Okay, so it printed 4. Yes, it printed 4.
Yeah.
Okay, so that means that the size of the array is 4. Well, how can the size of the array be 4? You pass it 10 elements, right?
Mm-hmm.
Yes or no?
Yeah.
Right, but it's saying that the size of the array is 4. Why? It's saying the size of the array is 4 because of something I said before.
It's an int type array.
I'm sorry?
Oh, it's an int type array, and so an int has 4 bytes.
Actually, that's not true. Make that a long. Make that a double, right? In where you say in main, make that a double array. Make that instead of int, turn that into a double. So doubles are 8, right? Yeah, double. And run it now. Run it now. I think you'll still see 4. Yeah.
There's an error.
Where's the error? Oh, because it's
Because int.
Okay, no, up in find max. Find max.
Find max.
Find max also return that int. In find max on line 7, turn the int into a double.
No, the you know the one in the
inside.
parentheses.
No, inside. Yeah, okay.
Oh, you want me to change? Do you want me to change right here or inside?
Put int there. Put int there. Put int back there. Okay, all right. So change the int array into a double array. Inside the parentheses where it says int, so turn that into a double. Okay, all right. So now if you run it now, you should still see 4.
Yeah, it's still 4.
Yeah. So even though double is 8 bytes, and the reason for that is because it is not printing the size of the array. It is basically printing what it got, and what it got was not an array. It got what I said before, right? It got the address, the pointer. It got the memory address of the first item. That's all it got. It didn't get an array, so it doesn't know. So if you use native arrays in C++, functions don't know that they got an array. They only know that they got a pointer, an address. So an address is just 4 bytes, and that's why it only says 4. So in order for this to work, if you pass native arrays, you got to pass one more thing. You got to pass the number of elements in the array. Unfortunately, you got to pass that too. So when you call find max on line 19, say comma and 10 right there. No, comma. It takes 2 parameters now. Yeah, comma, and then space 10. All right, so that is the number of elements in the array. Now we can make it even better, right? We can make it even better. Well, we will get back to making it better, right? So passing it 10, and up there in find max, on line 7, after double array, comma, comma, and then say length, L-E, int len, or size t len, size t space len. That's t, size underscore t.
Yeah, size underscore t. Oh, you forgot to remove an L at the beginning of size t.
Yeah, and then
does this mean that the function only looks at what you tell it to look at?
Yes, yes. The function only looks at what you give it, right? LEN is enough, I think, because the spelling is wrong anyway. It's not GHT, it's GTH. LEN is, yeah, just LEN. Yeah, okay, all right, fine. Okay, now in the for loop, now change all the doubles to ints too, right? We don't need to, yeah, just double click and change that to an int. Double click and int, int. And same thing in the other one, inside, yeah. Okay.
Oh,
now,
wow, I didn't know you can double click.
Yeah, int, turn that into int. Okay, and in the function, remove the, remove, yeah, comments, get rid of the comment. Yeah, right, okay. Okay, now you know, and you can get rid of the C outline. You don't need the C outline anymore in on line 10. Yeah, actually triple click on the line. Triple click on the line. Triple click. Okay, now hit delete. Okay, all right, now J less than, on line 9, J less than, now you know what to put there, yes?
The length.
Yeah, right, J plus plus. Semicolon, J plus plus. Now inside of this for loop, now you can do that check that we talked about, right? So now, now you can say, it's only one statement, but that's fine. You can still use the braces, okay? So if, if, yeah, type in if, yeah, if array of J, oh, you need, you need parentheses, okay? Array of J, no, you parentheses, if parentheses, no, if open parentheses, if, and then open parentheses, yeah. No, open parentheses, hit open parentheses. You got a bilingual keyboard, right? I think, right? Because you got a, have you got a keyboard that has 2 languages on it? Because yeah, because you're taking, yeah, I'm just guessing because it's taking you longer to find keys. Yeah. All right, so
maybe,
open parentheses.
I wonder if maybe it might be best to maybe, you know, switch to the English keyboard while coding.
No, he's got a, he's got a physical keyboard that is
bilingual.
Yeah, yeah, okay, yeah, there you go. All right, so open parentheses, and then array square bracket J. If array square bracket J is greater than max, if array square bracket J is greater than max, then max equals array square bracket J, yeah? And then in the end, you can return max. Oh, Peter was here. Oh, there he is.
I'm still here.
No, I mean my squirrel.
Okay.
That was funny.
Yeah. Yeah, no, you should be able to run it now. You should be able to run it now.
Oh, okay. Why I'm getting wrong?
Oh, I'm not looking, by the way. Sorry. Array of J. Oh, no. If array of J is greater than max, then max equals array of J. Yeah. If your hypothesis about the max is wrong, then you just need to change your hypothesis.
Under if.
Yeah. So someone can talk. Yeah, thank you, Susanna. I'm trying to figure out how to
return.
Switch the camera in my.
Array J. Max equals array J.
And remove the return. Remove the return. Got it.
There he is. But he's still eating.
Oh, we didn't. I think, do we output it?
Yeah. You just return it. You return max at the end. Return max, and then in your main, you can say max equals whatever it is. You see Peter? He's sitting there. Oh, you got to look at my iPad screen. Anyway, there he is. Okay, so if you run it now, you should be able to see the maximum number.
Okay, so
Did you see it? Did it work?
yeah, it works, and then I shared this is the solution, the result.
My max is OE.
Ooh, oh, wait a sec.
That's wrong. No.
Did you forget parameters when doing cout? I think you did.
Okay, can you fix it? Can you show me the code again, or one of you can fix it if not?
I think he passed the address of the function instead of the.
Instead of the array.
No,
Oh,
so yeah.
So what you need to do is whatever find max returns. Oh, yeah, you can put the function call right there. You can say, let's do it easier. Okay, let's do it the better way, right? Or not the better way. Let's do the more easier to understand way for, right? Okay, so on line 22, say int max equals int max equals int
Yeah. Okay.
int, yeah, space max equals. Okay. All right. Now on line 23, where you say find max, you can change that to just max. There you go. It is it 108? Do you actually have 108 in there?
Yeah, this 108 is maximum.
Great. Okay. So all right, go back to your code and let's make some more changes. Okay. So now let's get around this limitation of arrays, right? Get around this limitation of arrays where every time you pass an array, you also got to pass a size, and it's a real pain. So that's why people actually vectors are so useful. So let's try and use vectors for now. There's something else about arrays that I wanted to talk about. Let me see if it comes to me. Arrays. That's it.
Professor?
Yeah.
So what happens if, let's say, the length is 0?
I'm sorry? Oh, if length is 0. Yeah.
Returned.
Okay. If length is 0, then this program will crash because you're trying to access an element in the array that does not exist, right? So Robert brought up a very, very important point. Okay. So right now, so let's go to line number 8. And we're going to make a fix. We're going to fix this program so that it is more robust, okay? Which is basically what Robert basically did, just did right now, okay? So on before line 8, open a new line before line 8, right? Before line 8, okay? Now, if length equals 0, it has to be within parentheses. You got to get into the habit of always typing these conditions within parentheses. Yeah, if length double equals 0, right? Then you don't want to touch the array at all, right? Because if you touch the array when the length is 0, then you're basically screwed, right? So open or close there, and then on the next line, well, here typically people don't use squigglies because it's just a straight quick return, right? So you can say return. You got to return. So here is what is called a sentinel. Okay? A sentinel is a known illegal value. And you use that in functions that need to return a value and also indicate whether they succeeded or failed. And sometimes you write a function which is supposed to do something and return a value, right? Now, what happens if the function did something and didn't succeed? It failed. How would you know that the function failed? The only way you know function failed is if the function told you, right, that I didn't do my job. But in this case, the function is supposed to return a value and it's an integer. There's no way it can signal to you that the integer is, right? So there's two ways. There's one way in which you can actually engineer a function that.
Is that where you use like throw? Is that where you use like throw an exception or something?
Yeah. No, forget about throws and exceptions for now, right? So we're not talking.
No, I meant throw.
Yeah. That's where you use exceptions. But I'm talking about when you don't use exceptions, right? So how would you signal back? So one.
You return a 0.
But how do you know 0 is an integer? What happens if I send you an array in which 0 is in fact the maximum number? Well, what happens if I send you a bunch of an array with a lot of negative numbers and a 0?
Oh, then 0 is going to be returned.
Then 0 will be returned. Then how can I tell if the function failed or whether 0 is really the maximum?
Can you see out?
No, no, you should never ever. They're all good questions, right? Chad asked a very good question. No, find max is an internal function, an interior function. Remember what I said before. When I take my car to a mechanic, right? I don't expect the mechanic to call me, right? I expect the store manager to call me. Yes.
Yeah.
Right. So main.
You return nothing.
Main.
Like null.
No. How do you return nothing or a null? So it returns an int, right? So how do you return? What do you return?
Maybe you specify some number as like your sentinel. Is that right?
Exactly. Right. So that is called a sentinel. So what Robert just said, it's a sentinel. A sentinel is a known illegal value that you know for sure. You got to be 100% sure, guaranteed that the sentinel value is never going to be encountered in your data. Right. If you're sure that the sentinel is never going to be encountered in your data, then you can use a sentinel as an illegal return. Yes or no?
Yeah.
Okay, all right. So in this case, I am going to make an assumption, right? I'm going to make an assumption like most programmers do, right? Saying that I'm going to process arrays of numbers, but I will make sure that the minimum possible number ever, minimum possible number, it's actually called, I think it's called int underscore min, all uppercase, right? Int min. I think it's some huge negative number, right? It's, yeah, magnitude wise, right? So it's a minimum number. So I'm going to say that number is never going to be in my data. Right? If I see that number in my data, then I won't run this program, right? So if I'm confident that number will never be in the data, I can use that number to signal that a function that returns a number failed, okay? So here I would say return, I think it's int underscore min, okay? We'll find out. No, uppercase, all uppercase. Int underscore min.
I see it.
Yeah, there it is, int min. Okay. In fact, you can, at some point later on when you have time, just print out, see out int min, and you can see what it is, right? Int min, it'll be some minus 2 billion or something like that, right? So it's a negative 2 billion. So
remember semicolon.
Semicolon. And then put a comment there for beginners, right? This is because people will be watching the video and they don't, right? We assume, so in the comment, we assume that int min will never be part of the real actual data. We assume that int min will never be part of the actual data. Important.
So
right?
if Anand, so if int min is part of the actual data, then you can't use this method,
You can't, yeah.
the other way is to use exceptions. Is that right?
No, you can figure out other ways of doing this. One way to, you can use exceptions, obviously, but if you don't want to use exceptions, because, ideally me too, right? I try not to use exceptions as much as possible, right? I use exceptions when you have to, because exception-driven code sometimes gets, especially
it's kind of messy.
Yeah, for simple things, exceptions get messy, right? So if you want to do that, one way to do that is if I want to have int min, then what I would do is pass an extra parameter by reference. We never got a chance to cover this, and we can cover this next class, right? It's called passing a parameter by reference, passing by value, right? And when you pass a parameter by reference, the actual parameter gets passed. So if the function makes changes to that parameter, then even in the caller, the parameter would have changed, right? So I'll show you how to do that. I'll show you how to do that in two different ways. Let's do it with the Sentinel first, and I'll show you how to do it with the with the other thing. Okay. So type in this comment.
I was to say also in this case, if int min might be in the data set, but it would still be right if it were the maximum, because we would return it, right?
Yeah, but
like in the remote possibility.
If int min is in the data set, it can't be a unique maximum unless the array has got only one element, right?
Yeah. That was just saying, like it could theoretically be in the data set and be the max, but not a unique max. It's just saying, but it would still be right anyway.
Yes, it would be right. Yes. But we still need to have a way to tell, and that's what we're doing here. And yeah, you can fix a spelling error, but you still spelled length wrong, but that's fine. So we assume, we assume not the length is 0, right? We assume, nothing to do with the length here. We assume that int min will never be part of the actual data. That's what we're saying, right? We assume that int min will never be part of the actual data.
Oh, you forgot the never.
Yeah, will not be whatever, right? So will not be in the actual data. Will not be in the actual data. Int min not in data, right? Yeah. Never. Be in the data. Yeah. Be in the data. Yeah. Okay. So now if int min and then bam 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 and it returns max, and if yeah, it returns int min if the array is empty. Right now, you can in your main, yeah, further down in your main, yeah, you can say after you get the max value, you say if max equals int min on the next line. If max equals int min, not there, before on the previous line. Yeah, there. Enter. If max double equals int min. No, not comments. If max double equals int min. And you need to get in the habit of every time you type an if, you got to type an open parentheses. Are you a Python programmer?
Yeah.
Okay. All right. So you got to get in the habit. Okay. Max double equals int min underscore min. Okay. Then here you're going to say, yeah, then the next line, then cout array is empty. Cout array is empty. Empty, and then here you can return 1 to the operating system, saying that not everything is hunky-dory, something failed. Okay, so yeah, array is empty. Type in array is empty, and then /n for the new line. Array is empty, /n for the new line. Inside, yeah, /n. No, \n. Yeah, and yeah, semicolon. No, just semicolon right there. Semicolon. And you can get rid of the space before the /n because it's never going to be visible. Before the /n, just before the /n, you got a space. It's not going to be seen. Yeah. Okay. Right. And on the next line, just say return 1. Return 1. Right. So if the array was empty, it's going to print array is empty, and it'll return with a status of 1 to the operating system. The operating system will get a status, exit status of 1, which means that the operating system can now tell that the program didn't do its job. Yes. Okay. Otherwise, it prints the max, and then it returns 0. Okay. Now, if you run it, you should actually, it should work, right? If you run it, it should work. Did it work? It worked, right? Okay.
Yeah,
now,
I just show the result.
Yeah. Okay, go back to your code. All right. Now, make that my array. And then get rid of everything after the square bracket, right? So then get rid of the square bracket and everything. In other words, so my array, and then make that, I don't know, C++ let you declare a 0 element array. Make that a 0 element array, right? So yeah, open, close, nothing in there. And then turn the 10 into a 0. So, excuse me. Turn into a 0. Turn the 10 into a 0. Okay, run it now. And let's see if, oh, actually C++ does not let you declare a 0 element array.
You have to change the method instead. I think you have to change the method instead.
Yeah, no, but that's fine. I was hoping that I could also show you that the other thing that we built in is saying if the array was 0, it would return int max. But you can figure that, you can play around and figure that out. Now what we'll do is do that other way. Yeah, using the second variable, right? Say second value, right? So here, go back to that function. Go back to the function. All right. Now instead of passing after size t length, say comma. Okay. Now say bool space. No, bool. Yeah, ampersand. Put an ampersand there. Bool and then ampersand. Oh no, bool space. space.
Bool space.
Bool, a B-O-O-L, bool. It's a Boolean variable. Means Boolean parameter can only be true or false. Yeah, a bool space ampersand, which means it's something is getting passed in by address, right? So by reference, ampersand. No, shift 7. Okay. Now success or succeeded. S-U-C-C-E-E-E-D-E-D. Okay, now get rid of the space after the succeeded, and then get rid of the space before the succeeded too, right? Because the ampersand is attached to the succeeded. Okay, now that means succeeded is a Boolean flag that got passed into our function. If our function succeeded, it is going to set succeeded to true. If it failed, it's going to set succeeded to false. Okay, so now you can get rid of instead of you have return int min. You would say return 0, because you don't care at this point. Return 0, right? You can return any value, right? And before you say return 0, you're going to say succeeded equals false. On the previous line, you say succeeded equals false, right? And then you can get rid of the comment, false. And then you can get rid of the comment because we're not using that int min sentinel anymore, right? We're not using sentinel. Now here, below, where you actually set the max, right, before the final return, right? Now there you said, no, before, on the previous line, say succeeded equals true. Yeah, now in your main, you can actually test the value of succeeded, and you have to declare a variable, right? After, before you call the function int max, say, declare a Boolean flag, right? On line 25, go to the beginning of line 25 and new line there. Okay, so I say bool succeeded equals, call it something else, bool passed or something, right? Okay, you can call it the same name if you want. Okay, yeah, equals. Oh, just say that's it. Semicolon right there. All right. Now you're going to pass this variable into your find max function as the third parameter. So on the next line, find max my array comma 10 comma. No, you already have it. You already have that line, right? So right there you go. Find max my array comma 10 comma. No, go to after the 10 comma succeeded. So you're passing that variable into the function, and the function is going to set the value of that variable, right?
You need to change my array from 0 to 10 or some other number.
I'm sorry?
You need to change my array from 0 to a different number.
Oh, yeah. Okay. All right. Yeah, make that 10. Just give it 5 numbers.
Oh, and Joseph, do you know, I think the reason why I think you have to declare length for the array?
Yeah.
I think it has to know so it can allocate enough memory, right?
I'm not quite sure what you're saying, Chad. So I'm sorry. Just put in some numbers there. Let's.
So you know how arrays have a fixed length.
Yeah.
I think the reason why I have to declare size at first is so the program can allocate enough memory, right?
No, the compiler allocates enough memory as soon as it sees the array declaration right there. As soon as it sees that line, it allocates 40 bytes right there. Right now, you should be able to run this program, right? No, hang on. No, we're not done yet. Succeeded. Yeah. If max equals int min, you would say if succeeded. If not succeeded, get rid of the condition. Yeah, and then say if exclamation mark not succeeded. Exclamation mark is not. Bang, exclamation mark. Yeah, not succeeded. Succeeded. S-U-C-C-E-E-D-E. No, if not equal to, if not. Yeah. No. If vertical bar. Not vertical bar. Exclamation mark.
Where I can find it?
And exclamation is above 1. Shift 1. Yeah, and then get rid of the space. Get rid of the space there. Okay, that basically says if not succeeded. Is that okay? Do you understand? Is everybody okay with that?
I know this.
Yes or no? Nobody's really responding. Yeah, and only now I'm looking at the chat window here. Ben wants this copy to be shared on Discord. By the way, you know, I'm not following Discord. Okay, you guys can have a private conversation and discussions there. But if you want me to chime in, it has to be on Reddit because I'm not looking at all these other places. But certainly you can share this on Reddit and Replit and all these other places. Put it on Replit. Is there a way to make a resizable array? Yes. All of these are possible. Okay, I'm going to show you vector. Use a vector. If you use a vector, you can keep resizing. Okay, it's much easier. You can resize arrays too, but it's a little bit of a pain. But all of that is pretty much routine. So you know the system basically says, you know, use a vector. That'll do the resizing for you automatically. Boy, we got like 3 minutes left. Here, what we can do now is, this is a working program, right? So if you run it now, it should work. Now, what we can do is, if one of you can take this program and then turn this into using vectors instead of arrays, right? And then share it on Replit and Reddit, that would be great. And then we would be using vectors and you'll see the difference. You'll see the difference between using vectors and using arrays. And oh wow, so if I use vectors, and there's no cost difference, right? And the vectors cost about the same thing as almost, right? Just take a bit more extra space, but in terms of runtime, they're exactly the same, almost. Right? So use a vector. If not, on Tuesday, what we'll do is we'll take this program. Hopefully someone should share this program. So we'll pick up this program, maybe use vectors on Tuesday, and then talk about objects and other things. You know, we'll bring some other things to bear on Tuesday next class. But ideally, right, we should be done with this before even next class, right? So if someone can pick this up and use vectors, and also talk about reference parameters and copy parameters, you know, parameters being passed by reference versus copy. We've done all this in lectures before, so that's why I'm not talking about it, right? So you got to look at the previous quarter and watch the lectures, describe what a reference parameter is, copy parameter is, what it means to pass something by reference, pass something by copy. All those things you need to know for the exam, right? Not for this, maybe for the exam, I don't know. Yeah, functions part of this exam, right? You need to know. So read up on all of those things. And make sure you know about functions, arrays, just, you know, preliminary arrays like what we've done before, not serious stuff, and then control structures, if, then, whiles, and expressions, and that should set you up for the midterm.
If vectors are auto resizable and they're no slower than arrays, what's a scenario where you would use an array over a vector?
Well, typically I hardly ever use an array these days, right. But I do use an array when I know for sure that I have a fixed amount of data to process, and this is exactly how many doubles I'm going to read from a flat file. Yeah, but when I know that, then I'll basically just do an allocate in memory of that many bytes and read it into memory. Then I know, right? It's just indexing. Right. But even then, yeah. Also, you know, you'd use an array when you want to read an entire block of data from disk directly into memory, right? So instead of reading it 1 byte at a time, like if you do cin or getline and parse, and if you don't want to parse, and if the data file itself is stored as data, not as, you know, something that needs to be parsed, as data, as 4 bytes, 4 bytes, you know, these are actual numbers stored, right? If you want to read that data file into memory as a block, bam, right? So this data file, which is 2 terabytes, is going into memory as, you know, 50 billion integers, right? And I would read that, bam, like that, as a block. That's really, really fast, and I can read that into an array. Right. So yeah, otherwise I use a vector. Once you have a vector, the vector is, you know, if you keep resizing a vector frequently, yeah, obviously you're going to suffer hits. But even then, for vector resizing, the operating system does things very, very, you know, cleverly, because, you know, unless if you want to, if vector is this big, and then you decide I want the vector to be this big, and you say, well, resize the vector to this big, it's just a matter for the system to say, well, internally I have noted the vector ends here. All I need to do is change that to make the vector end here. So it'll just change the endpoint, right? Very rarely what happens is that, growing from here to here is not possible because something else is here, right? So in that case, the operating system knows, well, I can't grow from here. I can't grow from here to here because there's something here. So what I need to do is take that and look for some other location in memory where there's more contiguous free space. Then I'll move these fellows here, right? These people, I move all of them to there. There I got space to grow here, right? So the operating system will do that growing, but you won't even know. Everything is taken care of for you, and you can do all that. And yeah, with vectors, things are fast, as fast as arrays. Most of the time, arrays. The compiler will optimize the right things for you. Does that make sense?
Cool. Yeah, thank you.
Was this a useful class?
Was.
Fia, Fia, yeah, I have a question for Fia. Hey, Fia, if you had not come up on stage and started typing in, do you think there's a difference? Do you think that you actually have a slightly better grasp now of arrays and all these things we did today than if you were just a passive bystander?
I mean, yeah, it's really helpful, especially, well, but I mean, I keep confused by the Python, so, but yeah, actually, it helps me a lot.
Yeah, I think so. I think so too. Yeah, I think coming up here definitely helps you. It saves you a lot of time. Saves you a lot of time before the exam. Otherwise, these things, if Fair hadn't come up here on screen, he would be spending 2 hours mastering this topic, right? But now, before the midterm, he only needs to spend 10 minutes because all of this will come back to him, right? So imagine 10 minutes versus 2 hours. It's a lot of time. All right, great. Thank you very much. I will see you guys on Tuesday. I hope you're all coming back.
Professor, I was gonna ask. Personally, I've already done quests 1 through 4, but I was wondering when the freeze day is. Is it today? I thought.
No, it's Sunday. It's Sunday.
It's Sunday. Okay.
Yeah, we got
and how do we actually check like our full trophies? Like
you mean you've never checked so far?
Well, I've checked for each like individual quest, but I haven't like gone onto my like overall trophies, if that makes sense, and looked at.
Oh wow. Okay. Well, you know what? You should ask this question on Reddit because maybe there's other people have. Because this question has been asked like 5,000 times.
Yeah.
Yeah. There is the site.
Just check the syllabus.
Michael,
it's in the syllabus.
I was looking in the syllabus, but yes, I will.
No, here, Michael just sent it to you in chat. So you can just click that and enter your student ID. You'll see your scores.
Okay. Thank you.
All right. Okay. All right. Thank you very much. It's been a fun class, and I will see you on Tuesday where we'll take this to the next level. Okay.
Got it. Thank you.
All right. Bye.
Thank you.
Bye.
Thank you, Professor.
Thank you. Bye.
Oh, it actually helped me a lot. Yeah. Thank you.
All right. Okay. All right. Cool. Bye.
Bye.
One last question.
Yeah.
How do you know if you got all trophies?
Well, you got to find out. You got you can only get as much as you can. All right.
And I think the number is not decimal if you got them all, right?
Yeah, you can ask that question also in the forums. Yeah.
Got it.
Okay.
Bye.
All right. See you guys later.